There are four fundamental forces in the universe: electromagnetism, weak, strong, and gravity. Electromagnetism is mediated via photons, weak via bosons, strong via gluons. We theorize that gravity is mediated by undiscovered particles known as gravitons. But gravitons are a conundrum because infinite energy appears in their renormalization calculations, which predict how super tiny particles move around. Physicists try to get rid of these infinities through renormalization calculations, but that doesn't work in our standard model of physics. If particles were points like the standard model predicts, then the existence of gravitons just wouldn't work. But if particles were stringy, then the existence of gravitons would be A-OK. String theory is an attempt at a quantum mechanical model of gravity, that is, gravity can't be quantized, which makes it so that a measurement of gravity can't be divided, just like the other fundamental forces. This is important because it connects a lot of other theories. All matter is made up of fundamental particles that come together to make up larger particles such as protons, neutrons, and atoms. In string theory, one-dimensional strings oscillate in different ways to form different particles. The most popular form of string theory is superstring theory. Superstring theory solves an important problem with string theory. You see, strings vibrate.
And at the lowest possible vibration, mathematics makes it seem as if a string can have a value of energy that's the square root of a negative number, imaginary.
Which, simply put, is impossible. That would cause a string to become a particle that goes faster than the speed of light. Which, simply put, is impossible. So physicists thought of an obvious solution to this lack of energy: supersymmetry and more dimensions. Supersymmetry is a theoretical add-on to our standard model of physics, and it introduces new ways for a string to vibrate, causing it to have more energy. And more dimensions allow for more energy at the lowest vibration. There are many different types of superstring theory, but they all pointed to 10 dimensions. Theorists thought that 10 dimensions were a bit too many dimensions, so they tried out compactification, where theorists try to mathematically turn dimensions into fewer ones.
The Clowns-Klein theory, upon which compactification is based, should make it so that the extra 6 dimensions of space are wrapped up in these geometrical structures called orbifolds, which are pretty crazy.
It tries to solve the extra dimension problem by wrapping up the 6 extra dimensions around the dimensions that we perceive. But physicists played around with unifying all the different types of string theory. Instead of compactifying a dimension, they uncompactified one. So now there are 11 dimensions! Eventually, physicists unified the theories for the most part to come up with a new and improved M-theory. M-theory is a conglomeration of all the superstring theories that was derived from trying to introduce supergravity into the world of string theory. At the most basic level, supergravity is an attempt to paste the supersymmetry model onto the standard model of physics that we have now. So what M-theory tries to do is fit the superstring theory model in with the rest of the world of theories, a final puzzle piece for a million other theories to start working together, be it grand unification, neutrinos, black holes, etc. The point is that M-theory was the first possible grasp at a theory of everything! The entire complex theory is a stepping stone towards figuring out the entire universe, and I'm very happy to share this minuscule part of it with you. Thank you.